All right, welcome back to Daily Math Concepts. What we're going to be looking at today is a Regents exam common core for persons in New York City. This exam is done like twice a year, in August and in February. We're going to be looking at some sample questions here, and I will be giving as best as possible solutions in relation to those questions. All right, let's look at number one. It says, which ordered pair is not, and we want to underline the word not, is not in the solution set where y is less than, y is greater than negative half x plus 5, and y is less than or equal to 3x minus 2. There are a number of ways we could approach this, but I'm going to approach this by using the substitution method. Please bear in mind that these are coordinates that we have. So these are all coordinates that we have right there. So what we're going to be doing is to test the x coordinates in the function and then in the inequality, and then see the y value that we get, and we're going to match it back with the y's here. Please do remember that for every coordinate that we have, that first number, this is always the x followed by the y. Okay, so these are all x's followed by y's, and x's followed by y, x followed by y, x followed by y. So I'm going to be testing all the x's and then see if the respective y value matches the inequality, because y should be greater than here and y is less than or equal there. So we're going to be using that. The first ordered pair that we're going to be testing is going to be 5 and 3. So what this means, then, I'm going to be plug in 5. I will be plugging 5 where x is, and then I'm going to see if the value that I get for y is greater than 3. All right, so we want to test that. If that works, then it is correct. And then over the other side, I'm going to plug in the value here and see if the value I get for y is less than or equal to 3, because we should be getting 3. All right, let's go. So let's test it here. It says y must be greater than negative half x plus 5. So y must be greater than negative half x, but x is 5. All right, so I'm going to be plugging in 5 there plus 5. Let's quickly work this out, right? All right, so we're looking at y, which is greater than, this is 2. Hold on. This is 2. This is half. All right, 2. All right, good. So we're looking at, this is basically negative 5 over 2 plus 5, which is actually negative 2.5 plus 5. So negative 2.5 plus 5, and that will give us positive 2.5, right? So as you could see, this is suggesting that the value of y must be greater than 2.5. And indeed, the value of x was 3. The value of y was 3, and 3 is greater than 2.5. So this is good right now. So this is okay. We want to try this with y is less than or equal to 3x minus 2. So y is less than or equal to 3x, but x is 5 minus 2. So y is less than or equal to 15 minus 2. So y is less than or equal to 13. So you could see here that y must be less than or equal to 13. Indeed, 3 is less than or equal to 13. So because when we substitute the value of 5 in both inequalities, the answers were really satisfying to the inequalities. All right, that means 5, 3 is a solution. But I'm not looking for a solution. I'm looking for a pair that is not a solution. So I'm not going to choose that. So I'm going to try 4 and 3 next. All right, so we're going to be testing 4 and 3. All right, the moment I get something that is not satisfying these inequalities, then that's the answer. It's not in the solution region. So we're going to test 4, 3. Remember that x is the 4 and y is the 3. So let's write our inequality. Our inequality is that y must be greater than a negative a half x plus 5, right? So as you could see, so y is greater than negative a half, and then x is 4 plus 5. Now let's break this down. Y is greater than This could cancel. As you could see, we'll get 2. So this is negative 2 plus 5. This is saying that y must be greater than 3. Definitely, this is my y value. And my y value is 3. And 3 is not greater than 3. So that means this is false. This does not satisfy the inequalities, because y is 3. And this is saying that y is greater than 3. It is not greater than 3. So I'm going to stop here. For 3 is not a solution. All right. So it's not a solution. So the answer is 4-3, which is number 2 response right there. All right, let's move on to the next case. All right, for this other case that we have here, we're going to be trying, it says if the quadratic formula is used to find the root of the equation x squared minus 6x minus 19 is equal to 0. The correct roots are. So these roots are in surd form, no problem. What we want to do is identify what is A, what is B, and what is C. So let's list it. A is the coefficient of the square of x, which is 1. B is the coefficient of the x, which is negative 6. And C is the coefficient, it is the constant term, that is, which is going to be our negative 19. We want to highlight the fact that A is 1, B is negative 6, and C is negative 19. What we're going to do is to substitute these in the quadratic formula. Here goes. The quadratic formula says that x is equal to the opposite of b, or you could say negative b, plus or minus the root of b squared minus 4ac, and all of this must be over 2 times a. What we're going to do is to substitute values for a, b's, and c right now. So it says minus b, and b is negative 6. I'm going to put it in a bracket. We have plus or minus the root of what? B squared, and that is going to be negative 6 square plus minus, should say 4. All right, so we have minus, hold on, there was my pen, minus 4 times a, which is 1, times c, which is negative 19. Okay, and all of this must be over 2. All right, so 2 times 1, which is 2. Let's go a little further. This part, though, based on the fact that these are 2 negatives here, is going to be a positive. So that is just going to be 6 is going to be plus. So 6 plus or minus the root of 36. And then this will give me 76 all over 2. And let me continue. This is going to be 6 plus or minus. When we add these, we'll get 112 over 2. And this is where it comes down now to being very accurate at what you do. We're not going to be trying to find a decimal value there, because this is not a perfect square. But definitely we can find the product of a perfect square and another number under there. So basically then, x is equal to 6 plus or minus the root of 16 times 7. So we're going to have to understand our own timetable here so that we could master this. So this is 6 plus or minus. When radical rules, we could flip this as root 16 times the root of 7. All of this is over 2. We're going to take another step. X is equal to 6 plus or minus the root of 16, 4, and then root 7 over root 2. And this is when we could split our responses, because watch this. We're saying that this is 6 over 2 plus or minus, right? 4 root 7 over 2. Now let us use 2 to cancel. 2 into itself one time, 2 into the 6, that is 3, 2 into itself one time, and 2 into the 4, that is 2. My final answer is x is equal to 3 plus or minus 2 root 7. So I'm looking for that as my answer, and definitely my answer is at number 1. All right, so there it is. We were able to come up with that in radicals or surds, as you could say. All right, so number 1 would have been the appropriate answer there by utilizing the quadratic formula. All right, let's go to question 3. All right, question 3 says it's a statistics question. So it says, which statistics would indicate that a linear function would not be good fit to model a data set here. When the correlation, right, if you do have your correlation here, if the coefficient of the correlation is very near to -1 or +1, this is actually suggesting that we have linear stuff going on here. So these two are linear because this is close to -1 and this is actually 1. So when the coefficient of our correlation is a number close to -1 or 1, then we have a linear function. That's fine. But we are going to talk about the residual here. With the residual here, there are two things that we could think of. One, we need to see equal number of data set above and below the x-axis, right? And this kind of already suggesting that, because I'm seeing 4 above, 4 below, which would suggest then that a good fit would be to go between that, which would have been a straight line here. So this is good. The issue with this one is that I'm seeing 3 things up here and then 4 under there. That's 1. And then another thing, I'm seeing a pattern. We're not supposed to see pattern with this residual if it's going to be linear. So if you look at this, I'm seeing a pattern here where I could end up getting something like a quadratic curve there. I'm seeing that. You understand? So this won't work. So this one will not give me a linear. So my answer is definitely 3. All right. So 3 would be the answer for that. Number 4. For number 4, it says here that on the set of axes below, graph the function represented by y is equal to the third root of x minus 2. And we have a domain from -6 to +10. What I'm going to do is to quickly put some numbering here. So just watch me as I put some numbering here. That's a 0, that's 1, that's 2, that's 3, 4, 5, 6, 7, 8, 9, 10. So I have numbers up to 10. So I'm going to try to put this -1, -2, -3, -4, -5, -6. So my domain is from -6 to +10. So I'm not going to pass that. So it simply means that I'm not going to put any arrows at the end of my diagrams because I'm starting at -6 and I'm stopping at +10. All right. All right. I could just put some numbers like 1, 2, 3. This would be -1. This is -2. This is -3. So I'm just putting on some numbers to give a sense of direction to what I'm going to do. Let me explain what I'm going to do now. Because y is equal to the third root of x minus 2. All right. I'm definitely, based on the domain that I have, I am going to be picking on some numbers. I'm not going to do every single number from -6 to +10 because a lot of them, the third root is going to be a decimal number and not an integer. I want to get an integer here. Why? Because the axis that I have to plot on, I will not be able to properly pick where the decimals are. But I could set it up in such a way that I could pick probably 5 values that would give me 5 values from the domain that will give me an integer, and that will give me a good understanding of what's going on. For example, I'm going to be substituting values here at x, and then when I take away, so I'm going to, let me just mark this. I'm going to substitute values here at x, and when I subtract 2 from that, I'm going to set this up so that I will get values like 1, -1, 8, and -8. Why? Because we know the cube root of those values easily. So I'm going to do some substitution under here, but I'm going to make sure that the values that I get out are 8 or -1. For example, the first one, I could do them on the side here. The numbers that I'm going to be choosing, I'm going to be choosing -6, because when I put -6 here, I'm going to get a -8. I'm also going to be choosing, so -6, I'm going to be choosing +1, all right? And I'm going to be choosing 2, I'm going to be choosing 3, and I'm going to be choosing lastly 1, 2, 3, 4. I'm going to choose 10. So these numbers will give me back either a 8 or a 1, or a -8, -1, and I definitely know the cube root of those just like that. So let's plug them in. So basically, if I have y is equal to the third root of, I'm going to put -6 here, -6 minus 2. So I'm substituting -6 for x there. You could see that I'll have the cube root of -8. The cube root of -8 is -2. So that means 6 would have would have plotted with -2 right there. That's 1 point. So I'm going to leave, I'm just going to keep dropping in here. So the next one is going to be, I'm going to put 1. 1 minus 2 will give me the cube root of -1. Definitely the cube root of -1 is -1. So that means that 1 would plot with -1 right there. All right, let's go again. I'm going to be using 2. So if I have the cube root here of 2 minus 2, I'll definitely have the cube root of 0. And the cube root of 0 is a 0. So 2 will go with 0 right there. And then the next one I'm going to be using is 3. So let's look. 3 minus 2 will give me the cube root of 1. And then the cube root of 1 is still 1. That means 3 plotted with +1. All right, 3 plotted with +1. Lastly, I'm going to be using 10. So 10, let me put it on this side. So 10 minus 2 would give me the cube root of 8. And that is definitely 2. All right, so 10 actually goes with 2. So this is the sort of curve that I have. I'm going to use my freehand to do this, all right? I'm going to use my freehand to do this, so don't crucify me for the turnout of this. All right, so I'm just going to use a freehand and try to connect this. So I'll do this. All right, so basically that's the curve that we're looking at there from right there. All right, so the bottom line is I focus on the cube root here, understanding that only a certain numbers will give me the cube root here based on the domain that I'm using. So I select those numbers so that I could get 8 and 1 or 0 underneath my cube root sign. Then I'll be able to get some integers to work with. All right, so that's what the curve should be looking at. Please bear in mind that you're not expected to put any form of arrows at the end because the domain started at -6 and it stopped at +10. So arrows would have suggested that it goes to infinity, which is not the case. All right, so no arrows on the end, and that's what the graph should look like. Let's go to the last question. Question 5. Question 5 says solve 8m squared plus 20m, which is equal to 12 for m by factorizing. So we're going to solve for m by factorizing. But one of the key things with factorization is that when I'm factorizing, the first thing I look for is, do I have a common factor? In order to start though, let's subtract 12 from both sides. Because it's a quadratic, everything must be equated to 0. So we're going to subtract 12 from both sides to achieve that. The second thing I'm doing now is to factorize out 4. Why? Because I see that 4 is a common factor. So when I factorize out 4, what I'm looking at is actually 2m squared plus 4m minus 3, and this is equal to 0. Definitely, when we look on the inside, we can factorize this part now easily. All right, so I'm going to factorize out this part easily. So the 4 is there, but if I could just open 2 brackets and just work this out. This is 2m, there's going to be m here, there's going to be a 3 there, there's going to be a 1 here. So this is going to be, I'm looking for a positive, oh, this is 5 here, hold on. Okay, this is a 5, all right, everybody, right there is a 5. So that's fine, that's my error, that's a 5, all right, good. All right, 5, all right, so we're still on course. All right, error of 4 should be a 5, all right, good. All right, so then we're saying that what we're going to have here is a positive 3 and a negative 1, because if we try to follow this out, we'll definitely get back all of this, and that's the key. We want to make sure that when we follow this out, we're looking back at that. So basically 2m minus 1 into m plus 3 is equal to 0. At this stage, we'll say either, because if things multiply to give 0, then you want to say that, guess what? If things multiply to give 0, then it's either all of these are 0 or one of them is a 0. The thing is, we wouldn't know, but definitely 4 is not a 0. I'm sure that 4 is not a 0. So 4 is not going to be in my calculation right now because 4 is not a 0. So I'm going to be focusing on 2m minus 1 and m plus 3. One of these or both of them are 0. So we'll say either 2m minus 1 is a 0. Yet if not, it's going to be m plus 3 is a 0. So let us continue. I'm going to add 1 to both sides here. All right. In adding 1 to both sides, 2m is equal to 1. So if I divide by 2, one of my answers is that m is equal to positive 1/2. Secondly, if I subtract 3 from both sides, then this is suggesting that the next response is m is equal to negative 3. So here are my responses. M is equal to negative 3. M is equal to 1/2. All right, there it is. Please like, share, subscribe to the channel, and look out for the next video. Thank you.